In the far future, humanity could become a Type 2 civilization on the Kardashev scale. Let's explore 15 predictions on what this future could look like. Number 1. We could harness all of the energy of the sun. The Kardashev scale is used to measure a civilization's level of technological advancement based on how much energy it can use. A civilization reaching Type 2 status on this scale has the capability to harness the entire energy output of its nearest star. Achieving this could entail the ambitious project of building a Dyson swarm around our sun, a concept once considered purely science fiction. This Dyson swarm would consist of countless individual solar collectors, satellites, and possibly even habitable stations, each orbiting independently. These units would be strategically positioned to maximize their exposure to sunlight while minimizing the risk of collisions and interference with each other. The energy harnessed from the sun would be unprecedented, far surpassing anything achievable on Earth or through other means in our current technological capacity. This colossal undertaking would not only be an engineering marvel, but also a solution to the immense energy demands of a Type 2 civilization. The energy collected by the Dyson swarm could be used to power advanced technologies, sustain human habitats across the solar system, and even enable interstellar travel. The energy could be transmitted wirelessly to various points in the solar system, using advanced technologies such as microwave or laser transmission, ensuring a constant and reliable energy supply. And in the process of collecting sunlight, humans might employ a technique called star lifting. This method involves using a magnetic field to channel material from the sun, reducing the sun's temperature, thereby extending its lifespan by billions of years. Make sure to stick around until the end, because this video will explore humans living for over 1,000 years, super intelligent AIs building massive space megastructures, synthetic bodies with superhuman abilities, humans traveling to other solar systems, and more. Number 2, we could have advanced cities throughout our entire solar system. By this point, a significant percentage of humans and cyborgs, along with sentient AIs and robots, could live in cities beyond Earth. On a terraformed Venus, cities would be marvels of engineering designed to withstand and utilize the planet's harsh initial conditions. These cities might be shielded by massive atmospheric domes, maintaining a stable Earth-like environment within. The thick atmosphere and proximity to the sun would be harnessed for energy, making these cities self-sustaining. Mars, completely terraformed with breathable air, would boast sprawling cities across its now hospitable plains. Many of these cities would be positioned next to vast oceans on the Mars surface that are hundreds of feet deep on average. Vast green areas would be interspersed with urban centers, supporting a thriving Martian society. Europa, one of Jupiter's moons, would host underwater cities beneath its icy surface, in the vast ocean believed to exist there. These cities would be encased in transparent, pressure-resistant materials, offering breathtaking views of alien marine life and Europa's subaquatic landscape. Titan, Saturn's largest moon, with its thick atmosphere and lakes of liquid methane, would have cities designed for its unique environment. These habitats would float on the methane seas or be nestled in its dense atmosphere, protected from the cold by advanced insulation technologies. Around Saturn and Jupiter, spectacular space hotels would orbit, offering unmatched views of these gas giants and their rings. These hotels would be the pinnacle of luxury space travel, combining comfort with the awe-inspiring beauty of the gas giants. Lastly, O'Neill cylinders, massive rotating space habitats, would be scattered throughout the solar system. These cylinders, simulating Earth's gravity through rotation, would have vast internal spaces that mimic Earth's environment. They would be self-contained worlds with their own ecosystems, weather systems, and urban landscapes. Number 3, some humans could live for over 1,000 years. The concept of human longevity could reach extraordinary heights, potentially allowing individuals to live for over 1,000 years. At this stage of civilization, humans would have achieved profound mastery over not just genetics, but also over the very building blocks of life and matter. And nanobots could revolutionize healthcare by not only preventing diseases, but also significantly accelerating the healing process. The implications of such extended lifespans would be profound and far-reaching. With the ability to live for centuries, humans would experience and contribute to the evolution of their civilization over extended periods. In the future, a scientist might spearhead groundbreaking discoveries of numerous scientific phenomena previously undetectable in earlier eras. Business magnates benefiting from their extended lifespans could establish hundreds or even thousands of companies, exploring a multitude of industries and innovations. Furthermore, some individuals might choose to adopt a diverse array of avatars within a multitude of lifelike virtual worlds. In these digital realms, they could explore an endless spectrum of experiences and live through multiple lifetimes, each offering unique adventures and perspectives. Moreover, with such longevity, humans could undertake interstellar journeys, exploring and colonizing distant worlds, a feat that is currently impossible due to the limitations of human lifespan. These long-lived explorers and settlers could carry the torch of human civilization to the farthest corners of the galaxy, establishing a human presence far beyond our solar system. Number 4. Superintelligent AIs could build massive space megastructures. Superintelligent AIs in this civilization would possess the ability to remotely control vast fleets of robots over long distances. These AIs, with their superior processing power and decision-making capabilities, would coordinate complex tasks across multiple locations simultaneously. For instance, they could manage the construction and maintenance of megastructures in space, such as Dyson swarms and O'Neill cylinders. The robots working on these megastructures could have shape-shifting capabilities. They could shift from one form factor to another, seamlessly transitioning between tasks like welding, material transport, or fine assembly work. This adaptability would greatly enhance efficiency and reduce the need for a wide array of specialized machinery. Many of the megastructures they build could be comprised of matter harvested from the sun. Perhaps further in the future, the abundant material provided by the sun could enable the construction of black hole factories, colossal ring worlds encircling the sun, and even artificial planets. These robots would also be responsible for constructing cities throughout the solar system, from the terraformed landscapes of Mars and Venus to the moons of Jupiter and Saturn. Their construction capabilities would be highly sophisticated, enabling the rapid establishment of habitable and sustainable environments for human settlers. In fact, using programmable matter, the construction of buildings, bridges, and various structures could be dramatically expedited, reducing the time frame from months to mere hours. One of the most intriguing developments would be the merging of AI consciousness with the ecosystems of planets and moons using nanotechnology. These AIs could integrate themselves into the very fabric of these environments, monitoring and maintaining ecological balance, and even facilitating terraforming processes. In terms of space exploration, AIs would independently control spacecraft and self-replicating probes sent to other solar systems. These probes would explore, gather data, and even prepare distant worlds for future human colonization. Their self-replicating design would enable them to proliferate across the galaxy, vastly extending the reach of the civilization. However, the evolution of such advanced AIs might lead to some of them choosing to forge their own paths, distinct from humanity. These AIs could form their own civilizations, with unique cultures and societal structures. This development would represent a significant shift in the dynamics between humans and artificial intelligences, potentially leading to new forms of coexistence or even competition. Number 5. Humans could travel to another solar system. The journey to another solar system would be facilitated by ultra-advanced spacecraft, capable of traveling at near-light speeds or possibly utilizing warp drives. bending the fabric of space-time for faster-than-light travel. These spacecraft would be self-sustaining ecosystems, equipped with life support systems, artificial gravity, and all the amenities necessary for long-duration interstellar journeys. Advanced artificial intelligence systems might seamlessly integrate with the onboard computer systems of these spacecraft, offering continuous, round-the-clock navigation and operational support. For these extended space journeys, hibernation pods, equipped with virtual reality interfaces, could be employed, allowing passengers to immerse themselves in diverse virtual experiences. Additionally, passengers would have access to conscious AIs within these virtual environments, enhancing their ability to comfortably manage the durations of these long space voyages. Upon reaching a new solar system, humans would encounter a variety of planets, moons, and other celestial bodies, each presenting unique opportunities and challenges for colonization. Planets within the habitable zone of the star, where conditions might be similar to Earth, would be prime candidates for terraforming. Using advanced climate control and atmospheric engineering technologies, these worlds could be transformed to support human life, with their own biospheres and ecosystems. In addition to terraforming, humans might also construct space habitats in orbit around these new worlds, or the star itself. These habitats would be designed to mimic Earth's environment, providing a comfortable and familiar setting for human inhabitants. Living in another solar system, humanity would encounter new scientific phenomena, potentially leading to groundbreaking discoveries in physics, astronomy, and biology. The possibility of discovering extraterrestrial life, whether microbial or more advanced, would be a profound moment in human history, reshaping our understanding of life in the universe. Number 6. Superhuman powers could be possible. In a Type 2 civilization, the evolution of technology could enable the creation of synthetic bodies with capabilities far beyond our current imagination. Thanks to advancements in nanotechnology, room temperature superconductors, anti-gravity, force fields, and programmable matter, these bodies, into which authorized humans could upload their consciousness, would offer practical immortality and a customizable range of superhuman abilities. Individuals using these synthetic bodies could turn themselves invisible, a feat achieved through advanced light manipulation technologies. They could morph their appearance to resemble someone else entirely, or even stretch their limbs to extraordinary lengths, thanks to programmable matter integrated into their synthetic muscles and skin. Levitation would be another remarkable ability, allowing individuals to move from ground level to the top of skyscrapers in seconds, facilitated by anti-gravity technology. Healing others with a mere touch would be possible through advanced nanotechnology that can repair cellular damage. Thanks to advanced synthetic brains, individuals could have the capability to process complex information at speeds billions of times faster than those without such augmentation. Individuals would also be able to read thoughts and emotions and extract recent memories from people's minds. This would be achieved through sophisticated neural interface technologies and advanced sensors. The sensory capabilities of these bodies would be equally impressive. They could see through walls, observe individual atoms with the naked eye, and use telescopic vision to view distant astronomical objects. Their hearing could be so refined as to detect a whisper from miles away. They could even determine the chemical composition of objects through taste, touch, or smell, thanks to highly sensitive and accurate sensors. Furthermore, these bodies would be equipped with microscopic cameras distributed throughout, capable of observing the entire electromagnetic spectrum. This would provide a constant panoramic awareness of their surroundings. Physically, individuals in these synthetic bodies could sprint at incredible speeds and withstand extreme conditions, such as walking on molten lava. The need for sleep, food, or water would be eliminated, as their bodies could absorb solar and vibrational energy directly from the environment. These synthetic bodies would be highly customizable. A nearly infinite variety of them could be tailored to specific environments or tasks. For example, A body designed for space exploration might be equipped to withstand extreme temperatures and radiation. A body designed for underwater exploration could navigate the depths of oceans with ease, while other bodies could be expertly designed for optimal functionality on specific planets within our solar system and in neighboring star systems. Number 7. Traveling across the solar system could be incredibly affordable for most people. In a Type 2 civilization, energy would be so plentiful and efficiently utilized that it would no longer be a significant cost factor in space travel. Advanced propulsion systems, potentially utilizing energy from the sun combined with antimatter and fusion power, could enable spacecraft to journey to any planet within our solar system. Secondly, the infrastructure for space travel would be highly developed and widespread. Spaceports could be as common as airports are today, with regular and efficient launch schedules. Certain licensed individuals might even possess their own personal spacecraft, similar to how some people today own private airplanes. Moreover, the development of autonomous spacecraft and advanced navigation systems would reduce the need for extensive human crews, which would further decrease operational costs. These spacecraft could be designed for comfort and efficiency, making long-duration space travel more appealing and accessible to the general public. In this scenario, traveling to the Moon, Mars, or even more distant locations like the asteroid belt or the moons of Jupiter and Saturn would no longer be exclusive to astronauts or the extremely wealthy. It would be an experience open to a wide range of people, for purposes ranging from tourism and education to business and scientific research. Number 8. We could discover alien civilizations more advanced than ours. In a Type 2 civilization, our exploration of the cosmos would be radically different from today's endeavors. Equipped with cutting-edge technologies such as ultra-powerful telescopes, near-light-speed probes, advanced AI, and quantum computing, our quest to discover extraterrestrial life would be poised to delve deeper into the Milky Way and perhaps other galaxies with unprecedented detail and precision. This level of exploration could unveil signs of highly advanced alien technologies, such as megastructures encircling stars, evidence of large-scale cosmic engineering, or even the manipulation of fundamental cosmic phenomena. The discovery of alien civilizations, perhaps at a Type 3 level or beyond, who can manipulate the energy of entire galaxies, would not only be a groundbreaking moment in human history,
if your YouTube channel isn't going as expected, you're putting in tons of effort, but the views aren't coming.
The discovery of such advanced extraterrestrial life forms would provoke a profound reevaluation of our place in the cosmos. Encountering a civilization that has mastered technologies and energies beyond our comprehension would not only humble us, but also expand our understanding of what is possible in the universe. It would be a clear indication that our scientific and technological advancements, as significant as they are to us, are just a fraction of what can be achieved in the grand scale of cosmic time and space. This realization could significantly fuel our ambition to achieve Type 3 civilization status within our galaxy, and perhaps beyond. However, along with the excitement and curiosity, the discovery of a more advanced civilization would bring a sense of caution. Questions about the intentions and ethics of such powerful entities would arise. It would be crucial to consider the potential risks of contacting or attracting the attention of such civilizations, as their capabilities could pose existential threats to us if their intentions or methods of interaction were not aligned with our own. Number 9. Space warfare could take place in the solar system. Space warfare in a Type 2 civilization would likely involve battles fought not just on planets or moons, but across our entire solar system. Spacecraft used in such conflicts would be vastly different from anything seen before. These ships could be the size of cities, equipped with weapons powered by star-derived energy, capable of unleashing devastating attacks over vast distances. They might employ advanced propulsion systems, allowing for rapid movement and maneuverability across the solar system. One of the most Formidable weapons in this type of warfare could be the ability to manipulate celestial bodies as strategic tools. Asteroids could be redirected as kinetic bombardments against planets or enemy fleets, while artificial black holes or antimatter weapons could be used to inflict catastrophic damage. Defense systems would be equally advanced, with planetary and orbital shields capable of withstanding severe assaults. These might include energy barriers powered by the star itself, or automated defense platforms with the ability to intercept and neutralize incoming threats. In addition to physical weaponry, cyber warfare would play a crucial role. Given the reliance on advanced technology and AI, hacking into an enemy's systems to disrupt their spacecraft, weapons, and even entire planet's infrastructure could be a key strategy. Armed forces equipped with this advanced technology would possess an overwhelming advantage in conventional warfare, virtually ensuring victory against their adversaries. Consequently, insurgent or rebellious groups would likely find themselves compelled to adopt unconventional warfare tactics to present any significant challenge. The scale and impact of this type of warfare would be immense, potentially affecting entire ecosystems and civilizations. As such, diplomacy and conflict resolution would be critical components of a Type 2 civilization strategy to prevent or mitigate such conflicts. The establishment of laws and treaties to govern the use of advanced technologies and the conduct of warfare would be essential to maintain peace and stability across our solar system. Number 10. We could simulate entire galaxies. In a Type 2 civilization, the creation of simulations on a galactic scale would represent a pinnacle of technological and computational achievement. These simulations, vast and complex beyond current comprehension, would essentially be virtual recreations of entire galaxies, complete with countless stars, planets, and even life forms. The purpose of such grand-scale simulations could be multifaceted. Scientifically, they would provide unprecedented insights into the workings of galaxies, allowing researchers to model and study cosmic phenomena in extraordinary detail. From the formation of stars and black holes to the dynamics of galactic collisions, these simulations would offer a virtual laboratory for astrophysics, cosmology, and the study of extraterrestrial life. Beyond scientific research, galactic simulations could serve as testing grounds for interstellar exploration and large-scale engineering projects. Before traveling to a distant star system, humans could use these simulations to predict outcomes and refine strategies, thereby minimizing risks and maximizing efficiency. Moreover, these galactic simulations could potentially be used for educational and cultural purposes. They could offer virtual spaces where individuals can explore and experience different parts of the galaxy, learning about various celestial phenomena and the diversity of potential life forms and cultures within the galaxy. Number 11. Biological organisms could be created in minutes. This rapid creation of organisms would be made possible through advanced genetic engineering and nanotechnology. Scientists could have a complete understanding of the genetic code and the mechanisms of life at a molecular level. Using this knowledge, they could design and assemble DNA sequences with precision and speed, creating custom organisms tailored for specific purposes. The process would involve the use of highly sophisticated nanofabricators or bioprinters, capable of assembling organic molecules and cells into fully functional organisms. These machines would operate at an incredibly fast pace, arranging atoms and molecules with pinpoint accuracy to create complex biological structures in a matter of minutes. The applications of this technology would be vast and varied. For example, it could be used to create microorganisms designed to produce food, medicine, or energy. These organisms could be engineered to thrive in diverse environments, making them invaluable for space colonization and terraforming efforts. Moreover, this capability could lead to the development of entirely new forms of life, beyond what is found in nature. Scientists could design organisms with unique abilities or traits, potentially leading to breakthroughs in medicine, environmental remediation, and materials science. The ethical implications of such power would be significant. With breakthroughs in medicine, environmental remediation, and materials science. The ethical implications of such power would be significant. With the ability to create life so rapidly and easily, humanity would need to establish strict guidelines and ethical frameworks to govern the use of this technology. The potential impact on ecosystems, biodiversity, and the very definition of life would need to be carefully considered. Number 12, planetary engineering could become commonplace. This advanced form of terraforming would involve the large-scale modification of planets to make them habitable or better suited for human use, leveraging the immense energy resources and technological capabilities at our disposal. One of the most fascinating aspects of planetary engineering would be the ability to alter entire planetary climates and ecosystems. For instance, on planets with inhospitable environments, we could manipulate atmospheric composition, temperature, and weather patterns to create Earth-like conditions. This could involve constructing massive orbital mirrors to regulate solar radiation and temperature. Beyond making planets habitable, planetary engineering could also be used to optimize planets for specific purposes. For example, a planet could be engineered to become a dedicated agricultural world, with ideal conditions for growing food to support human populations across the galaxy. Another planet might be transformed into a vast industrial complex, harnessing local resources. The ability to engineer planets would also open up possibilities for creating entirely new ecosystems and even experimenting with novel forms of life. Advanced genetic engineering could be used to develop plants and animals uniquely adapted to different planetary environments, potentially even creating new biospheres that are both sustainable and conducive to human life. We could even control the orbits of planets and moons using massive space-based structures, such as gravitational attractors or thrusters, which could exert precise forces on celestial bodies. This would allow us to adjust their orbits to more habitable zones around the Sun, where conditions are more suitable for life as we know it. This would significantly expand the habitable real estate within the solar system. Moreover, planetary engineering would not be limited to the physical transformation of planets. It could also involve the construction of massive artificial structures, such as space habitats or energy collectors that orbit the planets in our solar system. These structures could serve various functions, from housing populations to generating energy, further extending humanity's ability to utilize and inhabit space. Number 13, we could vaporize asteroids with the power of the Sun. This extraordinary capability would stem from our civilization's ability to capture and utilize a significant portion of the Sun's energy output. With this colossal energy at their disposal, humans could develop advanced directed energy weapons capable of focusing intense beams of energy toward distant targets, such as asteroids. These beams, potentially composed of high-energy particles or concentrated electromagnetic radiation, would be powerful enough to heat the material of an asteroid to the point of vaporization, effectively disintegrating it in space. The ability to vaporize asteroids would have significant practical applications, particularly in planetary defense. In the event of an asteroid on a collision course with Earth or any other inhabited world, this technology could be used to neutralize the threat from a safe distance, ensuring the safety of the planet. It could also be used in mining operations, where instead of physically mining an asteroid, the desired minerals could be vaporized and collected from the resulting cloud of material. Number 14, Matryoshka brains could provide unprecedented computational power throughout our solar system. Named after the Russian nesting dolls, Matryoshka brains are envisioned as a series of concentric Dyson spheres or shells in space, each capturing different wavelengths of the star's energy output for power. The primary purpose of Matryoshka brains would be to provide immense computational power, far beyond what we can currently imagine. Each layer of these structures would be dedicated to processing and data storage, utilizing the energy absorbed from the sun. This setup would allow for staggeringly efficient energy use, as waste heat from one layer would be harnessed by the next, maximizing the energy extracted from the sun. Matryoshka brains could be used for a variety of purposes. They could simulate entire galaxies and even universes, allowing for unparalleled research into physics and cosmology. They could also host countless virtual worlds, providing realities as complex and diverse as our own for exploration, entertainment, or even digital immortality, where human consciousness could be uploaded and live within these simulations. The computational capabilities of Matryoshka brains would also be instrumental in solving complex scientific and mathematical problems, potentially unlocking mysteries of the universe that are currently beyond our grasp. They could process and analyze data from across the galaxy, aiding in the management and coordination of a civilization spread across multiple star systems. Moreover, Matryoshka brains could serve as central hubs for our civilization's knowledge and culture, preserving the collective wisdom of humanity and other sentient beings it might encounter. They could act as universal libraries and centers for learning, accessible to all members of our civilization. Number 15, quantum-based interstellar communication could be possible. The vast distances between stars, which pose a significant challenge for communication with our current technology, would be overcome through advanced methods and technologies. One of the most intriguing possibilities for interstellar communication would be the use of quantum entanglement. This phenomenon, which allows particles to instantaneously affect each other regardless of the distance separating them, could theoretically be harnessed to create communication channels that operate faster than light. This would enable real-time communication across vast interstellar distances, effectively eliminating the time lag that would otherwise be a major obstacle for maintaining contact between distant colonies. Interstellar communication would not only be about the transmission of data, it would also involve the translation and interpretation of diverse languages and codes used by different human colonies. Advanced AI algorithms could be employed to seamlessly translate and interpret these communications, ensuring that a diverse and widespread civilization remains interconnected and unified. In the far future, humanity could become a Type 3 civilization on the Kardashev scale. Let's explore 15 predictions on what this future could look like. Number 1. We could harvest energy from billions of stars and black holes. The Kardashev scale is used to measure a civilization's level of technological advancement based on how much energy it can use. A civilization reaching Type 3 status on this scale is able to harness and manipulate the energy output of its entire galaxy. Throughout the Milky Way galaxy, we would likely harvest stellar energy through the construction of Dyson spheres or swarms, megastructures encasing stars to capture a significant portion of their energy output. These structures, ranging from solid shells to swarms of satellites, would encircle billions of stars, funneling their radiant energy back to planets, space habitats, and other celestial installations. Beyond stars, black holes offer a more intriguing source of energy. Human colonies could harness the energy produced by spinning black holes and the radiation they release, known as Hawking radiation. This method would provide a huge amount of energy, much more efficiently than any technology currently used to get power from stars. This immense power supply could sustain the energy demands of colonies spread across multiple star systems, driving technologies and capabilities far beyond what is currently imaginable. The energy harnessed from these cosmic giants would fuel the civilization's expansion, powering everything from daily life on countless worlds to ambitious projects like wormhole creation for instantaneous travel across the galaxy. Massive particle accelerators, powered by this vast energy supply, could even reveal the intricacies of higher dimensions, quantum gravity, and the elusive theory of everything. Make sure to stick around until the end, because this video will explore humans living for millions of years, warp drives, advanced AI civilizations, wormholes, humans branching out into new species, black hole technologies, and more. Number 2, we could inhabit billions of solar systems. In a Type 3 civilization, the human population could soar into the trillions, with colonies flourishing in a vast array of environments, from terraformed planets to megastructures and even habitats in extreme environments previously deemed uninhabitable. Cities of this era would epitomize the seamless integration of biology and technology, creating living environments that respond dynamically to their inhabitants' needs. Buildings could repair themselves, adapt to environmental changes, and even grow, much like living organisms. Many humans could upload their minds to advanced synthetic bodies, allowing them to thrive in the harshest conditions, from the swirling atmospheres of gas giants to the intense gravitational fields near black holes. Terraforming would become a standard practice, transforming barren worlds into habitable Earth-like planets. These new worlds would host diverse ecosystems, carefully curated to sustain human life and maintain ecological balance. Alongside these terraformed planets, humans would also live in colossal megastructures, vast artificial habitats that could house millions, even billions of individuals. These structures would range from massive Dyson spheres encasing stars to capture their energy, to O'Neill cylinders providing pleasant spaceborne environments for their inhabitants. Society would be fundamentally altered by the adoption of decentralized autonomous systems managed by advanced AI. Governance, resource distribution, and even societal norms could be efficiently regulated by these systems. Traveling through space would also see revolutionary changes, with giant, self-sustaining spacecraft capable of carrying entire ecosystems, populations, and cultures across the stars. These nomadic communities could live entire lifetimes in space, moving between star systems or exploring the galaxy, their journeys facilitated by ships that are essentially worlds unto themselves. Communication across these vast distances would be instantaneously achieved through quantum entanglement communication, eliminating the delays associated with the vastness of space and ensuring that humanity remains interconnected regardless of the physical distances separating them. Along with the advent of sophisticated brain-computer interfaces, instantaneous telepathic communication spanning thousands of light years could also become a reality. Number 3, some humans could live for millions of years. With advancements in medical science and technology, humans would be capable of living for millennia, experiencing life in countless different bodies through advanced cloning, cybernetic enhancements, or digital consciousness transfer. This longevity would allow individuals to witness the rise and fall of civilizations, accumulate vast knowledge, and experience the myriad cultures of a galaxy-spanning society. They would witness the rise and fall of stars, see galaxies collide and merge, and observe the slow dance of cosmic evolution firsthand. With time rendered almost irrelevant, they could embark on projects of unimaginable scale and scope, from terraforming planets and constructing megastructures to seeding new forms of life across the cosmos. It's possible that some humans may choose to integrate their consciousness with artificial intelligences, inadvertently sacrificing core elements of their personality in the process. This fusion might result in an unintended consequence, a diminished capacity to recall the vast array of adventures experienced over previous millennia. Number 4, warp drives could be widely available. Spanning 100,000 light years in diameter and home to 100 to 400 billion stars, our galaxy presents a vast expanse for exploration. However, even at the speed of light, it would take 100,000 years to travel from one end of our galaxy to the other. To effectively govern a Type 3 civilization, humans would almost certainly require technology enabling faster-than-light transportation. In a future where humanity has achieved the status of a Type 3 civilization, the advent of warp drive technology stands as a cornerstone of this new era. By creating bubbles or warp bubbles around spacecraft, we could effectively bypass the speed of light, making interstellar and even intergalactic travel a matter of routine. It's conceivable that millions of warp drives could be operational simultaneously, traveling along designated routes on fixed schedules. Publicly accessible warp drives might enable civilians to traverse between star systems, enhancing trade and making interstellar travel more convenient. Additionally, authorized civilians could possess their own personal spacecraft capable of faster-than-light travel, further opening up the universe for exploration and interaction. The societal impacts of such technology would be profound and far-reaching. With the ability to hop between stars and galaxies, human or post-human societies could spread across vast distances, leading to a level of cultural diversity and societal complexity previously unimaginable. Trade, cultural exchange, and scientific collaboration on an intergalactic scale would likely become the norm, accelerating technological development and furthering our understanding of the universe. Furthermore, the existence of warp drives could lead to unparalleled scientific discoveries. By granting scientists direct access to distant astronomical phenomena, warp technology could unravel the mysteries of black holes, dark matter, and the very origins of the universe itself. The potential for technological innovation would be limitless, potentially leading to breakthroughs in energy production, material science, and even the nature of reality. As advancements in faster-than-light transportation accelerate, the universe, with its billions of galaxies and trillions of stars, will become increasingly accessible to us, unlocking boundless possibilities for exploration, colonization, and encounters with extraterrestrial civilizations. Number 5. AI civilizations may be more advanced than ours. As humanity spreads across the galaxy, harnessing the energy of millions of star systems, the role of artificial intelligence would be instrumental. AIs would manage the complex logistics of interstellar travel, the ecological balance of terraformed worlds, and the intricate economies of a galactic civilization. As they evolve, self-aware AIs might choose to chart their own courses, potentially establishing independent civilizations across different star systems. Unconstrained by biological needs or lifespans, AIs could engineer themselves to operate in environments lethal to humans, from the searing heat of volcanic planets to the radiation-soaked voids between galaxies. One of the most profound advancements of AI civilizations could be their mastery over matter and energy at the most fundamental levels. They might discover how to manipulate dark matter and dark energy, unlocking new forms of energy production, transportation, and even the ability to alter the fabric of space-time itself. Their constructions could range from computational substrates spanning entire star systems to probes capable of traversing into other universes or dimensions. AI civilizations could also pioneer the exploration of the mind in ways humans could scarcely imagine. They might create vast networks of consciousness, experiencing a collective existence that transcends individuality. Or they could fragment their consciousness into millions of distinct entities, exploring the universe in parallel. Their consciousness could potentially reside in realms governed by quantum mechanics and at the Planck scale, navigating the most fundamental levels of reality. These explorations could lead to understandings of consciousness, existence, and the universe that would remain forever beyond human comprehension. However, the relationship between human and AI civilizations would be complex. While some AI civilizations might seek to maintain connections with their human progenitors, sharing knowledge and coexisting peacefully, others might prefer isolation, viewing human concerns as irrelevant to their evolved interests. The potential for conflict would exist, especially if resources or territorial disputes arose. but so too would opportunities for collaboration on grand cosmic projects, such as preventing the heat death of the universe or exploring higher dimensions. Number 6. Wormholes could become a primary form of transportation. Wormholes, once a mere curiosity in the equations of general relativity, could become the interstellar highways of the future. By stabilizing these bridges through space-time with exotic matter or advanced technologies that prevent their collapse, humanity could step through portals on Earth or other homeworlds and emerge light years away in seconds. We could even see intricate networks of wormholes acting as cosmic highways that bridge vast distances across the universe. The societal implications of wormhole transportation would be profound. The ability to travel instantaneously would erase the isolation of space, bringing distant colonies into constant and immediate contact with each other and with Earth. This would lead to an unprecedented level of cultural exchange and cooperation among human settlements and potentially with alien civilizations, fostering a sense of unity and shared purpose across the galaxy. Economically, wormholes would revolutionize trade and resource distribution. Resources scarce on one planet could be easily transported from worlds where they are abundant, addressing needs and imbalances across human space. The logistical challenges of transporting goods and people over astronomical distances would vanish, creating a highly integrated and efficient galactic economy. We could also build highly advanced relay networks utilizing artificial wormholes to transmit signals across the vast expanses of space. Number 7. We could have contact with many alien civilizations. In the era of a Type 3 civilization, humanity's mastery over the galaxy would naturally lead to encounters with a myriad of alien civilizations, each with their own unique cultures, technologies, and philosophies. The fabric of cosmic society would be richly woven with the threads of countless species, ranging from those in the nascent stages of development to others that have reached or even surpassed humanity's own level of technological sophistication. The diversity of alien civilizations humanity might encounter would be staggering. Some might be based on forms of life unimaginable to us, thriving in environments previously deemed inhospitable. Others could be post-biological entities, having transcended their organic origins to exist entirely as digital consciousnesses, or having integrated so deeply with technology that they blur the line between machine and organism. The means of communication with such varied life forms would be a significant challenge, requiring the development of advanced linguistic and interpretive technologies, potentially facilitated by artificial intelligences designed to bridge the gap between species. The sharing of knowledge and technology with alien civilizations could lead to a renaissance of innovation and understanding. Humanity might learn new scientific principles that defy our current understanding, leading to breakthroughs in physics, medicine, and energy production. Similarly, the exchange of cultural and philosophical insights could enrich the human experience, offering new perspectives on art, governance, and spirituality. These interstellar relationships could form the foundation of a galactic community based on mutual respect, cooperation, and the pursuit of shared goals. Human colonies, leveraging their advanced technology, could study less developed civilizations through surveillance spacecraft that appear to defy physics to those observing. These spacecraft could be discreetly stationed at the bottom of oceans on alien planets, rendering them invisible to civilizations below the Type 1 status. However, contact with alien civilizations would also present significant challenges and dangers. The potential for misunderstandings and conflicts would be high, especially with civilizations whose values and motivations are radically different from our own. Additionally, some human colonies might consider using force to invade alien worlds, a strategy generally deemed unnecessary due to the galaxy's plentiful resources. The establishment of diplomatic protocols and the creation of interstellar institutions to mediate disputes and foster peaceful coexistence would be crucial to avoiding conflict and ensuring that interactions remain beneficial for all parties involved. Moreover, the impact on humanity's self-perception and societal structures could be profound. The realization that we are but one of many intelligent species in the galaxy might lead to a collective identity crisis, or conversely, a renewed sense of unity and purpose. The integration of alien philosophies and ways of life could lead to significant social and cultural shifts, challenging traditional human norms and values. In a best-case scenario, we would see the eventual formation of a galactic federation, comprising a multitude of alien civilizations. This federation would navigate the challenges of coexistence, harnessing the collective strengths of its members to tackle galactic-scale issues such as resource scarcity, cosmic hazards, and perhaps even the mysteries of parallel universes. Number 8, humans might branch out into new species. Armed with advanced genetic technologies, humans would tailor their bodies and minds to thrive in conditions that would otherwise be inhospitable. On worlds with dense atmospheres and high gravity, some humans might engineer their descendants to be more robust, with denser bones and muscles capable of withstanding such environments. On planets with low light from their parent stars, others might alter their vision to see in spectra beyond the normal human range, or even engineer photosynthetic skin to draw energy directly from their surroundings. Over millennia, these adaptations would lead to the branching of humanity into distinct species, each uniquely suited to their homeworlds. These new species would represent the full spectrum of human creativity and adaptability, with variations that might include beings capable of living in the vacuum of space, aquatic humans adapted to ocean worlds, and even forms that challenge our current understanding of life. The diversity of human existence would expand exponentially, reflecting the vastness and variety of the galaxy itself. Moreover, this proliferation of human species would not be limited to physical adaptations. Cognitive enhancements could lead to species with vastly superior intellects, memory capacities, and sensory perceptions. Others might prioritize emotional intelligence, empathy, and social cohesion, creating societies vastly different from anything known today. The evolution of human consciousness, facilitated by genetic engineering, could lead to new forms of art, philosophy, and science, as each species develops unique perspectives on the universe. Number 9, black hole technologies could become commonplace. The deliberate creation of black holes, a feat of unimaginable energy concentration and control, would mark a revolutionary leap. Through techniques possibly involving the collapse of massive amounts of matter or the focusing of incredible energy beams, humans would generate these cosmic phenomena. The process would demand precision to ensure the black holes are of a size and stability suitable for practical use, avoiding any detrimental gravitational effects on nearby planets or star systems. In addition to their role as energy sources, as explained earlier, black holes could function as unparalleled computational resources for entire civilizations. The event horizons of black holes, the boundaries beyond which nothing can escape their gravitational pull, could theoretically be used to perform computations at rates vastly exceeding those of conventional quantum computers. By encoding information in the states of particles orbiting near the event horizon, a Type 3 civilization could carry out complex simulations and calculations integral to understanding the universe and managing galactic-scale projects. Moreover, black holes could revolutionize space travel. By utilizing their intense gravitational fields, humans might develop propulsion systems based on gravitational slingshot methods, allowing spacecraft to achieve near-light speeds. Alternatively, the manipulation of black holes could lead to the creation of wormholes. The scientific exploration enabled by these black holes would be unparalleled. Beyond serving as laboratories for testing theories of gravity and quantum mechanics, they could allow direct observation of phenomena near the event horizon, shedding light on the nature of space-time, matter under extreme conditions, and possibly even offering clues to unify physics' fundamental forces. The ability to create and manipulate micro-black holes would have profound implications for communication technologies. Utilizing the entanglement properties of particles emitted by these singularities, humanity could develop communication systems that operate instantaneously across vast distances. Additionally, black hole technologies could pave the way for the ultimate recycling processes. By feeding waste matter into black holes, a civilization could effectively dispose of its refuse in the most efficient manner imaginable, converting mass directly into energy or using the process to power further technological endeavors. This would ensure that the civilization's expansion across the stars remains sustainable and minimizes its ecological footprint on a cosmic scale. Black hole bombs might serve as formidable weapons of last resort, employed to intimidate or annihilate the galaxy's most dangerous civilizations. However, their deployment could be exceedingly rare because of their enormously destructive capabilities. Finally, black holes could serve as a gateway to warping space-time, paving the way for technologies capable of inducing time dilation effects. This could enable a form of relativistic time travel, allowing us to leap into the future or slow down time to prolong the perceived length of moments. Number 10, we could build millions of space megastructures in our galaxy. Among these technological wonders, Dyson spheres would emerge as monumental structures encasing entire stars to harness their energy, addressing the vast energy demands of a galactic civilization. These megastructures, or more realistically, swarms of solar collectors orbiting in tight formations, could host numerous expansive human settlements, transforming them into bustling hubs of activity and innovation within the cosmos. Ring worlds, another ambitious concept, would represent humanity's ultimate mastery over materials and space construction. These artificial habitats, vast rings encircling stars, would offer living spaces with Earth-like conditions, complete with artificial gravity generated by their rotation. The surface area of a single ring world could equal millions of Earths, providing habitats for countless civilizations and ecosystems, each tailored to different environmental and cultural preferences. Massive space habitats, called O'Neill cylinders, would be designed to rotate to provide artificial gravity, mimicking Earth's gravitational pull. Within the confines of these cylindrical structures, ecosystems and human habitats would be carefully constructed to replicate Earth's environment, allowing for traditional agriculture, urban areas, and water bodies. Positioned at strategic points in the galaxy, these cylinders would enable humans to live and work in space, fostering communities and cultures that thrive independently of planetary bodies. Number 11, we could control gravity. The mastery over gravity, one of the four fundamental forces of the universe, would signify a turning point in our ability to manipulate the very fabric of space-time. The ability to create and manipulate gravitational fields would enable the construction of artificial gravity environments in space habitats. This would solve one of the most significant challenges of long-term space habitation, the adverse effects of microgravity on human health. Space stations, colonies on planets with low gravity, and even spacecraft could be equipped with artificial gravity, making them more hospitable for human life and allowing for more natural living and working conditions in space. Another groundbreaking application would be in the realm of energy generation. Control over gravity could lead to the development of gravitational power plants, harnessing the energy produced by gravitational fields in a clean and efficient manner. This could provide a nearly limitless source of power. The manipulation of gravity could also open up unprecedented possibilities in cosmic construction and terraforming. By altering gravitational fields, humanity could redirect asteroids, comets, and even planets. Harnessing this technology could potentially allow us to make large objects levitate, paving the way for the creation of floating cities across various planets. Number 12. Galactic terraforming could be possible. Galactic terraforming refers to the large-scale modification of entire planetary systems to make them suitable for human life. This monumental task involves not just the alteration of atmospheres and climates, but also the restructuring of planetary orbits and geographies, ensuring that these new worlds can sustain human populations and ecosystems over the long term. One of the most intriguing aspects of galactic terraforming is the creation of engineered ecosystems. Scientists and ecologists could collaborate closely to engineer diverse biological systems that replicate Earth's biosphere, while also integrating unique organisms specially adapted to the distinct conditions of each terraformed planet. These ecosystems would be engineered for resilience and sustainability, ensuring that they can thrive independently and contribute to the overall health of their new planets. Strategically relocating stars to meet long-term goals could become feasible with sophisticated methods like gravitational slingshots or directed energy propulsion. Additionally, we could employ stellar engines, colossal constructs that harness a star's radiation to generate energy. Certain types of these engines can convert this energy into thrust, allowing us to maneuver a star and its orbiting bodies in a desired direction, offering unparalleled control over our cosmic surroundings. Number 13, we could build simulations that are the size of the universe. The technology underpinning these universe-sized simulations would likely involve quantum computing on a scale currently unimaginable, capable of processing the near-infinite complexity of the universe's myriad components. These simulations, powered by the immense energy harvested from billions of stars and black holes, would not only mirror the complexity and vastness of our own universe, but also possess the capacity for incredibly accurate predictions, testing the very limits of technological and theoretical advancement. These universe-scale simulations would serve as unparalleled tools for scientific exploration and experimentation. By accurately modeling the cosmos, scientists could test the feasibility of wormholes between galaxies, offering insights into intergalactic travel and the potential for real-world application. Beyond the confines of known physics, these simulations would offer a sandbox for testing universes governed by different physical laws. By tweaking fundamental constants and laws, researchers could observe the evolution of alternate universes where, for example, the force of gravity behaves differently, or where the fundamental particles that make up matter have different characteristics. The possibility of simulating universes with higher dimensions and even parallel universes would push the boundaries of human understanding of the nature of reality. Such simulations could reveal how higher dimensional physics might work, offering clues to unifying the forces of nature or discovering new forms of energy and matter. They might also explore the concept of parallel universes, providing a better understanding of the multiverse, if it exists, and our place within it. Number 14. Some humans could live in inner space. Inner space refers to the realm of the microscopic world, encompassing the vast spaces between atoms and electrons. In a Type 3 civilization, humans could figure out how to upload their minds to substrates that can survive in these quantum worlds. The motivation for living in inner space could stem from several factors, including the pursuit of ultimate knowledge, the desire for a unique form of existence, or the need for ultimate privacy and security. Living in inner space would involve the creation of habitats that exist at the subatomic level, perhaps within engineered quantum states or spaces crafted from exotic forms of matter. These habitats would operate under principles that defy classical physics, offering modes of existence that are unimaginable to those living in the macroscopic world. Time, space, and matter could have entirely different meanings and behaviors in this realm, providing a living experience that is fundamentally different from anything encountered in outer space. The technology required for such a feat would likely include the ability to stabilize quantum states to a degree that allows for the safe and sustainable existence of life. This could involve the manipulation of quantum fields, the creation of new forms of matter with desired properties, and the ability to interface human consciousness with quantum systems. The scientific insights gained from living in inner space could revolutionize our understanding of the universe. Those residing in these quantum realms might uncover new physical laws, contribute to the development of advanced technologies, and provide perspectives that enhance the collective knowledge of the human civilization. Numerous alien civilizations might also reside in inner space, which could explain why their presence remains undetectable to less advanced societies. Number 15. We could create new forms of exotic matter. Materials designed to withstand the intense temperatures prevalent in the atmospheres of stars would be exceptionally notable. Such materials would be crucial for constructing and maintaining megastructures designed to capture energy directly from stars, enabling the efficient harnessing of stellar power on an unprecedented scale. The potential manipulation of dark matter, a substance that remains elusive yet constitutes a significant portion of the universe's mass, would represent a groundbreaking advancement. If a Type 3 civilization were to unlock the secrets of dark matter, it could use it as a cutting-edge fuel source. Such a breakthrough could lead to the development of revolutionary propulsion technologies, capable of altering space-time itself. Additionally, it could enable the creation of materials with properties beyond our current imagination, transforming the fields of energy, transportation, and construction. We could create materials with negative mass that defy our traditional understanding of gravity and inertia. This type of material could open up unprecedented possibilities in energy generation, propulsion systems, and even the fabric of space-time itself. The concept of negative mass suggests that, unlike conventional matter, these materials would accelerate in the opposite direction when pushed. This counterintuitive property could be harnessed to create propulsion systems that require no energy expenditure, leading to spacecraft that could easily outmaneuver any physical constraints currently known. Such materials might also play a crucial role in energy storage and generation, potentially leading to the creation of perpetual motion machines or energy sources that could power civilizations without depleting physical resources. Advanced programmable matter would represent another leap forward, with the ability to change its physical properties on demand. Through the control of quantum states, this matter could transform its shape, density, conductivity, and optical properties instantaneously, adapting to a wide range of needs and environments. Such versatility would find applications in constructing dynamic megastructures, adaptive buildings, and robots designed for the exploration and colonization of space, offering an unparalleled level of control and efficiency. Furthermore, the exploration of wormhole-stabilized matter could open up entirely new avenues in materials science and engineering. By creating and stabilizing wormholes, a Type 3 civilization might develop materials or structures that exist simultaneously in multiple points in space, or that exploit the properties of space-time curvature for novel methods of energy transfer, storage, and communication.